Hello student, today we will learn Young's double slit experiment which shows the interference pattern. Means this experiment demonstrates the interference pattern. For this, we take two sources of light. Two sources of light are known as coherent sources of light. What are coherent sources of light? The sources which emit the light of same frequency with constant or zero phase difference are called the coherent sources of light. For this, we take a single source of light and keep a cardboard or screen in front of this and make two holes. Now these sources are coherent source because they are coming from single source having the same frequency. This source must be monochromatic, means single color of light is used to show the interference pattern. Why we learn this interference pattern or Young's double slit experiment? Because we prove that light travels in the form of wave. This is known as double slit experiment because we are using here two slits. For this, we take these two sources of light S1 and S2 separated by distance small d, and at capital D we take another screen where we are observing the interference pattern. How we will get this interference pattern or what will be the pattern of interference? Here I will watch the interference pattern like this. We get here the bright and dark strip. Some strips will be bright and some strips will be dark. This pattern is known as interference pattern. If we take these two sources and at distance hota d, and these two sources are emitting light from here, then we get this strips dark and bright, dark, bright, dark, bright, dark, bright, which is called interference of the pattern. Since this pattern is based on wave theory, that is known interference pattern or double slit experiment done by Young. For this, we take at distance capital D a screen and take a point, arbitrary point from midpoint O, which is between source S1 and S2 at distance Y. Now, light is traveling from source S1 S2 like this, just like this. First wave is traveling like this and second is like. For demonstration or calculation, we are taking a straight line or in the form of ray. Otherwise, these sources are producing light in the form of wave. For point P, we assume that light is coming. If we get here constructive interference, then it depends on this path difference S2n. S2n is a path difference between two waves which decide the pattern will be the constructive or destructive. It is shown by Dale. To prove this, that here interference pattern is observing, it may be constructive or destructive. We take this part difference which decide the constructive or destructive interference. Part difference is S2P minus S1P, that is denoted by Dale. Equation number 1. To calculate this, we take in triangle S2PA and triangle S1PB. Here we use Pythagoras theorem, that is S2 P square minus S1 P square. That will be, if we take this triangle Then we get here S2A plus AP square minus here S1B whole square plus BP square. Now we can write this S2P minus S1P plus S2P plus S1P. This is equal to D square plus Y plus D by 2 whole square. Why? S2 is D and this distance is Y plus D by 2 because slit is separated by small d and we are taking this point O between A and B. So distance will be D by 2, D by 2. If we calculate AP, then it is equal to Y plus D by 2. Now similarly, this S1B equal to D square plus Y minus D by 2 whole square. Now, we are finding the path difference between these two waves. The path difference depend on this S2 and this will be equal to S2B, S2P minus S1P. We denote here del. As we know that path difference is important and wave length is just in order of 10 raised to power minus 12, 10 raised to power minus 11, etc. So we can assume that in addition, this may be equal to capital D and capital D because this point P is very close to point O. So we can write here D and we have importance of this part difference. So S2P minus S1P that is equal to S2N which decide interference pattern. So we take here D plus D, so that is equal to T2D. In calculation, if we take this negative d square cancel and this equal to y square, this y square cancel, d by 2, whole square cancel, a plus b whole square formula, then this can be written as d by 2 plus minus minus plus, then y 2y d by 2 that is equal to 2y d. Now this 2 cancel, we can write here y equal to del d upon small d. Now you can pause the video and calculate this y. If point P is at distance yn from O means nth interference pattern is observed. Suppose we are observing the nth interference pattern at point P which is at distance yn from O. So we can write here this yn equal to del d upon small d. This equation number 2. Number 1. For constructive interference. For constructive interference, what is condition of constructive interference? As we know, when crest or trough meet at a point, then resultant amplitude increases. Or we can also say when the path difference del equal to even multiple of lambda by 2, then we observe the constructive interference like this. Path difference is 0, then we can 2n lambda by 2, then we obtain constructive interference. Now we can write here Yn equal to n lambda d upon small d. This is the position of nth interference pattern from point O at point P. As we know that in constructive interference or destructive interference, there will be, suppose this is center, if we have two bright strips, there will be a dark strip which is known as destructive interference. Mean between two constructive or two destructive interference, there will be a another steps of opposite pattern. Means if we take two constructive, there will be a step which is known as dark fringe strips, or that is known as destructive interference pattern, which is known as fringe width. So we can also say here, if we take two consecutive bright interference pattern, then there will be a strips of destructive interference or fringe width of destructive interference, that can be written as yn minus 1, or we can also write here yn plus 1 yn minus 1. If we put here n plus 1 lambda d upon small d minus n d lambda upon small d, then fringe width of destructive interference will be d lambda upon small d. This n cancel, there will be only lambda d upon small d. This is the width of destructive interference. Means we get here destructive interference fringe width between two consecutive strips of bright or constructive interference pattern. Okay, now you can pause the video and note down. Clear? Now for the destructive interference, what is condition? For destructive interference. Now for destructive interference, what is path difference? Del equal to 2n plus 1 lambda by 2. Then we get here n fringe 2n plus 1 lambda by 2 into d upon small d, or nth interference pattern 2n plus 1 d lambda upon small d. As I already said, that between the two constructive interference pattern, there will be a dark strip fringe width. Similarly, between two dark interference pattern, there will be a bright or constructive interference fringe width, which is denoted by beta. That can be also written as yn plus 1 minus yn plus 1. If we put the value of this 2n in place of n, write n plus 1 plus 1 d lambda upon 2 d minus 2n plus 1 d lambda upon 2d. We also get this fringe width d lambda upon small d. You can calculate and find out that fringe width is lambda upon d. So we can say here fringe width either of bright or dark, it will always be equal to d lambda upon small d. Okay, so this is the calculation of fringe width of Young's double slit experiment. Now this fringe width gives that this fringe width beta proportional to capital D, beta proportional to lambda, and beta proportional to 1 upon d, or inversely proportional to small d. Now you can calculate this, and in next video we will learn more about this interference pattern.